Welcome back. We're on the last section of Chapter 2 covering differentiation. The next chapter, Chapter 3, still covers differentiation, but we're using it to find max and mins and other things. So we're going to use differentiation in modeling our story problems. All right, so in the last lesson, we did implicit differentiation, which let's just go over what that was again. So like if you took the derivative of all of this, which was taking the derivative of x and y, not solving for y first, that would be 2x dx over dx, because we took the derivative of x with respect to x, and then 2y, the derivative of y with respect to x, and then the derivative of 10 is just 0. So again, dx over dx is gone, so it's just 2x. So we were never writing dx over dx in the last, the last sections and all. But here, that's why that's dy over dx, because it's still there. And so what we're going to do then is what we did is remove the 2x over. And we solve for dy. So move the 2y, divide by it. And we got for the whole answer on it, negative x over y is what dy over dx equaled. Anyway, we're kind of doing the same thing with related rates, but everything is having the derivative taken with respect to time. Everything is taken with respect to time. So like, for example, a way that we can use that is when water is drained out of a conical tank, the volume V of the radius and the radius R and the height H of the water level are all functions of time. And knowing these variables, they're all related by the formula volume is pi over 3 r squared h. So we could take the derivative of everything there with respect to time. So I was comparing what we did before in the last lesson with the implicit differentiation, where we took the derivative of everything with respect to x, and that's what we've always done. But if you don't solve for y first, when you take the derivative of it, you got to leave dy over dx and then solve for it. We're not going to bother doing that in this section, but everything is going to be a derivative with respect to time. So, for example, on this one, taking the derivative of the volume, it would be the derivative of the volume with respect to time, and then that would be equal to, and got kind of the product rule going over here with the r squared times h. So I'm going to pull the constant out front and just leave it there. So pi over 3. And then I'm going to do the product rule on these. So the derivative of r squared is 2r dr over dt, because again, every variable is taken with respect to time, and then times the h, the second variable, and then plus the derivative of the second variable would be dh over dt, because the h is just, the derivative of h is 1. So it's 1 times it, or just dh over dt anyway. And then times the other one, which was r squared. And so that would be the derivative of everything with respect to time. And that's what we're doing today. And what's kind of nice today is you don't really have to solve for a specific variable like what we did up here. We solved for dy over dx and clean it all up. We're not going to bother cleaning it up today. We just take the derivative with respect to time and plug in the variables. So the first one here says x squared plus y squared equals 2y. So taking the derivative with respect to time, the derivative of x squared is 2x dx over dt, plus then the derivative of y squared is 2y dy over dt, and then 25 is just gone, it's 0. So that's the derivative of x squared plus y squared equals 25. So they'd like to know on letter A, what about if find dy over dt when x is 3, so I'm going to put 3 in for x, and y is 4, and dx over dt is 8. So dx over dt is 8, and the y was 4, and we're trying to find dy over dt. All right, so 2 times 3 times 6 is 48. And I'm going to move that to the other side and make it negative 48. 2 times 4 is 8. And I'm moving the 48 over, so it's negative 48. Divide by 8, and you get negative 6 for the whole answer. So dy over dt is equal to negative 6. Okay, and then letter B, we've already done the kind of the hard work. I know it wasn't that hard, but we already did it. We already solved for with respect to t. We've already taken the derivative, so we're going to use it again here on letter B. They want us to find dx over dt now when we've changed all the numbers. What about now if x is 4, y is 3, and dy over dt is negative 2? So 2 times x, and x is 4. We don't know dx over dt this time. That's what we're solving for. Plus 2 times y, and y is 3. And then times dy over dt, which is negative 2. All right, so that gives us 8. And 2 times 3 times negative 2. Let's see, that's 6 times negative 2, so negative 12. Move it to the other side, that's positive 12. And so dx over dt equals 12 over 8. Divide those both by 4, and you get 3 over 2. So dx over dt would equal 3 over 2. All right, so let's do a story problem. Or the fancy word to call it here with Common Core is modeling. Oh, actually, I don't think we're doing really a fun one. No, no, on the next page here, we're going to talk about the steps. Identify the given quantities. The quantities you're supposed to find. Make a sketch if you can. Oh, yeah, we're in the right place. Make a sketch if you can. And then number 2, write an equation. That's the big one. Write the equation, differentiate it with respect to time, and then plug in the numbers and solve for your missing variable. Okay, so write an equation, implicitly differentiate it with respect to time, plug everything in and solve. So the next one here, it's not a bad one. So we have y equals the cosine of x. They give us some things, and let's just solve for whatever's missing. So the derivative of y with respect to time is equal to the derivative of cosine, which is negative sine x, and we're taking the derivative of x on this problem. So it's the derivative of x with respect to time. And they said, what about if dx over dt is 4? So that's 4. And x is pi over 6. So negative sine pi over 6. Okay, so obviously we're trying to find on this one dy over dt. Somewhere I got the directions cut off, but that's what we're trying to find because that's the only thing that's missing. The sine of pi over 6, again, you need to memorize these things. It's a half. So that's negative 1/2 times 4. So the whole answer here is negative 2. Oh, and it's in centimeters per second. All right, and then on the next page, it doesn't get a lot more interesting, but we got a little bit of a story problem on the next page. But they give us the formula on it, so they've kind of ruined all the fun. Okay, it says the length S of each side of an equilateral triangle is increasing at a rate of 13 feet per hour. Find the rate of change of area when S is equal to 41 feet. Hint, the formula for the area of an equilateral triangle is A equals S squared radical 3 over 4. All right, so they gave us the formula. That's the big one. You've got to come up with a formula. After you come up with a formula, then you're going to implicitly differentiate it. So with respect to time. So the derivative of A with respect to time. Again, the A is gone. Just like the derivative of x is just 1. The derivative of A is 1. So it's 1 times that, or just the derivative of A with respect to time. All right, then we got S squared times this constant. Let's just pull the constant out front. So radical 3 over 4. And then we're going to take the derivative of 2s, of s squared, which is 2s. And then the derivative of s with respect to time is what we just did. All right, let's plug in the numbers. They said 13 feet per hour, and that was the length of s, the side change. So ds over dt is 13. And they said when s is 41, so we're going to put the 41 in for s. And bring down the 2 and the radical 3 over 4. So that makes the derivative of the area. The area is changing with respect to time of all that. So I'm going to cancel the 2 and the 4 twice. So on the top then we've got 4 times 3 times radical 3. Oh, shoot, and I left off, did I leave off ds over dt? No, I got it all. So then 4 times 13, let's see, so 4 times 13 is 52. I feel like I lost a number somewhere. So 2, let's see, radical 3 over 4, 2, s was 4. Oh, I know what I did wrong. S was 41. Son of a gun, that's where I went wrong. All right, so we're left then with 41 times 13, which is 533, times the radical 3 on the top, and then over 2. All right, and the area is feet squared per hour. So the area is changing at 533 radical 3 over 2 feet squared per hour. All right, so last page here. This one's a doozy. Gonna want to stretch out here for it. We can do this. A boat is pulling into a dock by means of a winch. Yes, I said it right, winch. 12 feet above a deck of a boat, see the figure. The winch pulls in rope at the rate of 4 feet per second. Determine the speed of the boat when there is 13 feet of rope out. What happens to the speed of the boat as it gets closer to the dock? All right. I'm going to call this the length of the rope. That side, we're going to call that x. So they want to know what happens to the speed of the boat as it gets closer to the dock. So that would be the letter x here. That's the boat coming in. So that's the speed of the boat coming in. So what we have here is Pythagorean Theorem going on. So it is x squared plus 12 squared equals L squared. That's what we've got. And a little tricky thing here, I don't know how much it'd take off for it if you didn't notice or know, but as the boat gets closer and gets pulled into the dock, instead of going out, when it's going out, it's positive. When it's coming in, the vector's negative. So technically, we're supposed to call this negative 4 feet per second. So put a negative on it. So taking the derivative with respect to time here on the equation, again, I pulled this out of the fact that they've got a right triangle. There's 3 sides, so let's do the Pythagorean theorem on it. I know it's not that intuitive, but there's quite a few problems like this. So if you ever see a right triangle anywhere, just do the Pythagorean theorem on it, set it up. You'll get some points for it on the AP test or on whatever test you're taking. So taking the derivative with respect to time, we've got 2x dx over dt. And then 12 squared, that's gone. And then that'd be 2L dl over dt. So we've got an equation. We took a derivative. Let's plug in the numbers we've got. So we have got here, and by the way, we know, they want to know, determine the speed of the boat when there's 13 feet of rope out. So when there's exactly 13 feet of rope out. So we can do the Pythagorean theorem to find the missing side of this triangle here on the first part here. So when you do that, we have 12, 13, and that side's x. So x squared plus 12 squared equals 13 squared. So 169 minus 144 is 25. So x is 5. So put a 5 in there. So it's 2 times 5. dx over dt. Let's see, what is this number? The negative 4, the wrench is pulling it in. Winch is pulling in the rope. So that's dl over dt. Because the rope is the letter L. So that's this number. So that's over there. So we know that one. And the length of the rope is 13 feet. So 2 times 13. And that number is negative 4 for dl over dt. So all we're missing is the speed of the boat, which is what we're looking for, dx over dt. All right, so we've got over here, let's see, 2 times 13 times negative 4, and then divide that by 2 times 5. So we got 13 times negative 4. I know, you're thinking, why does she need to divide that on the calculator? Because I'm really tired. let's see, divide that by 5 and you get negative 10.4. So the answer is negative 10.4 feet per second. The rope is being pulled in at a length of feet, and then the time that we're taking it with respect to time per seconds. All right, then on letter B. Letter B is even more fun. It says that suppose the boat is moving at a constant rate of 4 feet per second. Again, this time the boat is moving. So that's dx over dt. So this time they want to know if dx over dt is equal to negative 4 feet per second, because again, the boat's coming in. Determine the speed at which the winch pulls the rope when there is a total of 13 feet out. What happens to the speed of the boat? What happens to the speed at which the winch pulls in rope as the boat gets closer to the dock? All right, so it's still the same equation that we had up here. So what happens to the speed of the winch when it pulls in as it gets closer to it? So that's dl over dt. So we're trying to find dl over dt now. It's still the same equation here. I'm going to go ahead and cancel out the 2's because there's a 2 on both sides. So that leaves us then with x dx over dt equals L dl over dt. All right, so if the boat is moving negative 4 feet per second, so x times negative 4 equals, and if we had L, the length of it, so on the last one here, the L and the x actually are changing, and so we don't know what x and L are because they said that we're pulling in the boat, and we don't know where the boat is at. So we're trying to solve for dl over dt. So what we want to do is get rid of the L. So we're dividing by it and trying to find then the dl over dt. And you can't even see any of that, can you? So sad. All right, so I canceled the 2's out up there, which left then, let's see, I canceled it out up here. I canceled out the 2's up here, which left x dx over dt. The L and the dl over dt are left. And we're trying to solve for, again, they want to know what happens to the speed of the winch as the rope gets closer to the dock. And so again, that rope coming in to the winch from the boat is L. So what's the change of that? The dl over dt. So we're trying to find dl over dt, and they told us the boat this time is negative 4. All right, so, but the x and the L are both changing this time. We don't know what they are at all because it's coming into the dock. So what we're going to do, because we don't have either variable, we don't know either one. So what we're going to do is use the fact we have the triangle there with the x, and then we have the boat, the rope is L, and this is always 12. It's not going to change. So we have x squared plus 12 squared equals L squared. So what we want to do is solve for at least one letter. Let's go ahead and just solve for the x. So x squared equals L squared minus 144. So x is the square root of L squared minus 144. So x is the square root of L squared minus 144 over L times negative 4. And that would equal dl over dt. And again, we want to know as the boat gets closer and closer to the dock. So as the limit gets closer and closer to the number 12 from the right, because this rope up here, L, as it gets pulled into the dock, it gets closer. This rope pulls in, it's going to get shorter and shorter and shorter, and it's going to come closer to approaching that number 12. The rope's going to come closer to being the exact same length as that one. As it pulls into the dock, it's coming inward. All right, so as it gets closer and closer to 12, and now this is where it gets kind of funny. When you put the 12 in, because we can put the 12 in because it's a limit, you get 12 squared, 144 minus 144 is 0 over 12. So the whole thing is 0. So the limit are the speed of, what were we looking for? What happens to the speed at which the winch pulls in the rope? Well, it gets down to being 0. I don't know. I just thought that was funny. because of course it's going to be 0. It's going to stop working. It's going to be all done. So all that work just to say when it pulls it in, it's done. So the speed at which it pulls it in is 0. Anyway, I thought it was funny. I know you don't think it is. All right, I'll see you for the next lesson.